Here's our machine learning presentation for Real Estate 5100. So to start, meet the humans. Our team's made up of Evan, Grant, Lacey, Briggs, Caleb, and Hunter. And then to begin, here's just a little bit about machine learning. So machine learning is a certain type of AI that helps systems automatically learn and improve and build on their knowledge through experience without a human explicitly putting in input. And this field began development decades ago in the 1950s when IBM created a computer program that could play checkers. And then just a little bit on how machine learning works. So I'm going to explain this through the analogy of teaching a toddler how to ride a bike. So at the beginning of the machine learning, you collect a whole bunch of data, basically whatever the system is going to be using for its work. And this is the same as picking out like the type bike and all the different setups you need. And then next, you need to prepare the data. You need to make sure that it's in a format that matches what your machine learning algorithm will be able to deal with. And then, in the analogy of biking, this is where you wrap your toddler in as many pillows and knee pads, arm pads, and just get them in a good position to be okay, even if things don't go well at the beginning. Next, you choose a model. This is where you decide what type of parameters and how you want the model to function and what square one is going to be that they're going to build upon. And then in this is where you decide where the best environment might be to teach your kid how to ride a bike, where maybe you might want to go to a grassy hill or some place where they're not going to run off into a road, something like that. The next is training the model. This is where you take the model and have it go through a few easy steps so it starts to get an idea of what its task is. And this might be where you have a kid on a little bike with training wheels and you're holding and like barely pushing it along and just like start teaching the kid how they're going to go about riding a bike. Finally is evaluating. Things have gone on a little bit. There's been some training. Now this is where you look at the model and see, okay, what's working and what are some things that aren't doing well. This is okay. Does the kid know what's going on? Are they in a position where they're probably going to die if you let them loose? Next, you go and then make the small changes to the parameters and to the code that will allow this program to not make the mistakes that you've maybe caught earlier. And this is where you might be, okay, the kid is finally like starting to figure out the motions. I think it might be time to take it out to the real world or the sidewalk. Finally, you just have to set the model loose with all the data. And this is where you're finally at the point where you believe that the model is good to go and that it will provide valuable findings. And this is when you take off the training wheels and let the toddler fly.
I'm going to be talking about the types of machine learning. We've got 4 different types of machine learning, and we're just going to start with the first one, which is supervised learning. All this is a machine takes your past data points and it makes predictions based off of the past behaviors of those data points. And this model, in theory, is supposed to get better with every prediction. So as time goes on, the predictions should become more and more accurate. We've got 2 main categories of this, which is regression and classification. And a good example of supervised learning would be credit scores. All right, then we've got unsupervised learning. With this, the algorithm finds patterns in the data so that, in theory, no human interference is required, and it does this by analyzing and clustering data sets. An example of this would be recommendation engines. Basically, it segments your market by taking the buyer's data points and finding homes best tailored to their interests. All right, then we have semi-supervised learning. This combines both supervised and unsupervised learning. Typically, you're going to see this in situations where you're not able to easily acquire labeled data, but it's a little bit easier to acquire unlabeled data. A good example of this would be speech-to-text technology, and you could use this in a meeting between lenders and clients, and it would be able to transcribe the entire meeting and put it in a written documentation to have for legal purposes in case anything happened down the road where things would need to be transcribed. Just takes a little bit of the burden off of people. Then we have reinforcement learning, and this is different because it doesn't have an answer key the way that supervised learning has. So instead, it receives feedback after every decision it makes, and that ultimately makes it better and better with each time. An example of this would be a company like Blackstone Inc., which is an investment firm, and they would use this to optimize their investment strategies over time.
One might ask themselves, how does machine learning relate to real estate finance? Machine learning relates to real estate finances through a lot of characteristics like property characteristics, location data, market trends, economic indicators, and demographic information. All these factors really help, within a small margin of error, decide things that humans really have a hard time standardizing and calculating.
What are some examples of machine learning in real estate? Let's put all this information into a simple example. The year is 2024 and the Georgia Lottery numbers were just announced and there were two winners. These two winners were James Conklin and Uncle Ricky. Both recent lottery winners want to invest their new earnings into the real estate market. But the biggest difference between each winner is the application of the machine learning in this process. James is planning on using his AI to his advantage when it comes to valuing, purchasing, managing, and selling his property. Ricky, on the other hand, is not planning on using AI at all, but instead sticking with the old school approach of he said, she said to the real estate investment. Let's see how both of them do. With valuation, James' strategy and result is that he uses machine learning and started by using his search engine to find undervalued properties in his local area. The more he used his programming, the more in tune he became with the local real estate world. The machine gained the insight of a local investor and learned how to project cash flows of thousands and thousands of properties, the risk associated with each specific property, and the specific purchase price of each property. What happened was James found an extremely undervalued property in an upcoming area in Athens, Georgia.
Ricky went a different route. Ricky went to where everyone tends to talk business, his weekly poker game. Ricky heard from his old buddy Bill that the local high school basketball team got a new coach that was set to bring a championship to the city for the first time since '98. Bill says that the real estate market is going to boom in the areas surrounding as recruits' families flock to be a part of the new team culture. Bill says there is a lot of opportunity, and that's his valuation, as he shoves his pile of chips in on a pair of threes.
Now on to purchasing. James, after finding the most statistically perfect property, was now focused on the purchase of it now. James began to project interest rates in the upcoming 10 years and started to create a list of contacts on how to shop his loan with the very next day. The result was James managed to shop around and find a loan at a very extremely low interest rate and evaluate this loan in over a short period of time due to his streamline of calculations.
After taking Bill's chips, Ricky sets an appointment with the fella from his high school that got into banking, Jeremy. Jeremy and Rick didn't get along too well, but Ricky figures his lottery winnings will alleviate that stress. Ricky's wrong. Jeremy shows Ricky a property that was allegedly a crime scene. Ricky gets talked into signing on for a 1-year ARM with a balloon payment after 7 years, even though interest rates are trending up. Jeremy does a great job of convincing Ricky that these adjustments won't harm him because his ex-wife was in fact a fortune.
Now on to managing. James, after his new purchase, began to plan out his 10-year plan for the property and the most optimal design that would get consumers excited. After coming up with the perfect color scheme and rent for his property, he opened up his property to the market. After a while, James created a management schedule for all work orders, a checklist for legal obligations, and a machine-based tenant application process that would cut out unfit tenants for his property at moment's notice. And there are many more applications for this technology. The result was James streamlined his entire operation of management and learned how to change his rent to the upcoming market.
Ricky decides that he wants to rent his property out while he vacations with his new girlfriend. He tells his buddy that came to town he can pay him rent to stay there on a monthly basis, and they agree on a spit shake. Ricky comes back to the property after 7 months and 3 girlfriends of traveling. He arrives at his property to see that his friend has taken on a botany hobby and the overgrowth of the plants has enveloped the interior of the house. Ricky feels overwhelmed.
Now on to selling. James is now ready to exit the market and sell off his property at the very, very peak. James begins to search through thousands of historical comparables that have the same physical characteristics as his property. Same bed, same bath, same color scheme, same area. Streamlines it. He then creates a list of appraisers to reach out to give him a general baseline of what the purchase price is necessary for his property. After getting an amazing appraisal, he set his market price and opened the floodgates of consumers. This overhaul of interest in his property caused him to open up his new virtual tour aspect to smooth out the viewing process of his property. The result was James sold his property at a huge margin and brought home a ton of cash to reinvest. What James is going to reinvest in is machine learning.
Ricky is tired of the pain. He's had it up to his ears in real estate and now realizes he should have gotten into baseball cards when he had the chance. Ricky goes to his real estate agent friend, Chuck, and relays his woes with his investment journey. He specifies to Chuck that he wants to get the most he can in the quickest possible time, to which Chuck agrees. The next day, Chuck drives to Ricky's with 2 jet skis and a 4-wheeler. Chuck then gives Ricky a lesson on opportunity cost, and Ricky walks away feeling profitable. In summation, is AI worth it? Absolutely. As we've seen between the differences of James and Ricky, AI makes it much more efficient to streamline the process of buying and selling a home, to create a portfolio, streamlining operations and cutting costs, whether it's employee or tenant-based, detecting fraud in tenants, contracts, emails, and more, predicting changes in the market and the rent changes with it, and seeing the opportunity cost of different scenarios based on previous data. And no, that's not talking about jet skis.
Shot my brother Rose. You see I just pulled up in them skis. Rose, you see them yachts, rich forever. Oh, you think it's a game? I'm out here, boy, you know. We all neighbors.
What does the future of real estate look like with machine learning capabilities? There's many possibilities, the first of which is enhanced predictive analytics, automated personalized services, the integration of alternative data, improved risk management, and also lender assessment of clients. Enhanced predictive analytics. Machine learning models likely will become more precise in predicting property values, doing so by incorporating a wider range of variables, including environmental sustainability factors and social trends, among others. Also is market trend forecasting, in which future machine learning tools will offer more accurate predictions of market fluctuations, leveraging real-time data from a variety of sources, also including things like social media sentiment, economic indicators, and also geopolitical events. Next is automated and personalized services. Machine learning will likely enable highly personalized real estate services for clients, anywhere from property recommendations tailored to individual preferences to financial profiles for personalized mortgage advice. Next is the automation of processes, where routine tasks such as property appraisals, document verification, risk assessment will all become prevalent, reducing cost and increasing efficiency. The next is the integration of alternative data sources. For this, you can think of non-traditional data such as drone imagery, Internet of Things device data, and online behavior patterns, all of which can enhance machine learning models, providing deeper insights into property valuation and investment opportunities. Also, improved risk management, in which future machine learning models will offer more nuanced and dynamic credit risk assessments, incorporating real-time financial data and potentially even psychological and behavioral factors. Also is portfolio optimization. Machine learning will likely be able to develop sophisticated real estate portfolio management strategies using advanced simulations and predictive models to balance things such as risk and return dynamically. Lastly is the lender assessment of clients. Predictive modeling and risk assessment can use machine learning to assess things such as loan default risk. This will occur by analyzing extensive data such as borrower profiles, property details, economic factors, market trends, and even personal information. The model will be trained on historical lending data to predict default probability for new applicants. This will aid lenders in making precise loan approval decisions, which will minimize risk and reduce defaults while remaining profitable. Next is dynamic pricing and interest rate optimization for loans. Machine learning algorithms can consider many things from borrower creditworthiness, property type, LTV, market conditions, and even macroeconomic indicators. Real-time data and market trends can be continuously analyzed. The algorithm will dynamically adjust interest rates to reflect changes in these risk profiles and market conditions. Customized interest rates will be offered to individual borrowers with the goal of maximizing profitability while keeping the lender competitive.